Okay, here we go again. This is my second time shooting this video because the first take my hair was absolutely atrocious. And do you ever have just a bad hair day and then you sit down and you record something that you're going to post on the internet that hopefully millions of people will see and your hair's just not cooperating? Well, I hope that you never have to deal with that minor unpleasantry. There's worse things going on in the world, ladies and gentlemen. I shouldn't be complaining about my hair. In fact, I love the fact that I have hair. Why am I talking about hair in an engineering video? I have no clue, but hey, welcome to Drew's Lab. My name is Drew. So glad to have you guys here today. And today we are going to be kicking off a series called Printing the Printer. And you may be asking yourself, well, what does that mean? What is printing the printer really referencing? Well, this is
wait till you see the no
3D printer. In case you couldn't tell, this is a Creality Ender 3, and if you haven't seen my video of unboxing and assembling, check it out right here. But the whole idea or the whole culture around 3D printing and how it came to be this prominent and now new and amazing technology that everybody loves is it was born out of a movement called the rep-rap movement. And at the core of the rep-rap movement is this idea that we should be able to build, design, manufacture, produce, do all these magical things with a machine that can self-replicate. So basically you can use that machine, or you design a machine and you manufacture it in such a way that it is able to produce parts that you can then turn into more of that machine, and it continues to replicate over and over again, with minor other parts that you source from other places. But the vision is later down the road that every single part of a 3D printer could be 3D printed on a 3D printer. So we're not there yet, I hate to break it to you, but we do have the means and the parts and the ingenuity and the know-how and the amazing community of makers out there that we can get pretty close, and we can 3D print a majority of the parts that are required to print a 3D printer. And then the rest we can kind of usually just get on Amazon or at your local electronics store, what have you. So that is the goal of today's video. I am going to go through the process of, or the goal of this video in this series, I should say. I'm going to go through the process of building a 3D printer using parts that I printed on my current 3D printer. And I'm going to document all the trials and tribulations and fun shenanigans along the way and post them on the internet for you, the amazing viewing public, to enjoy and to look at and possibly gawk at, depending how hairy this gets. Hopefully there's a gem or a truth or a little microcosm, minutia, that's the word. There's a little minutia of truth or a minutia of inspiration to get people to get out and buy a 3D printer or get out and build their own 3D printer and learn all the cool stuff there is about these wonderful machines and all the cool stuff that you can do. I think it's an interesting time in the field of 3D printing because if you're a 3D printing hobbyist like myself, then you and I are kind of at the forefront of this technology becoming a thing. And I think about back in the day, like during the computer, like when computers started to get really, really popular around the 70s and the 80s, you had the mystical vision of like a bunch of guys in their garage like hacking stuff together, soldering stuff, and that's all well and good. I think that's where we are right now, but eventually nowadays, I build computers as kind of a hobby. I enjoy doing it. And if I want to go and I want to get some more RAM or get a new GPU, I just go down to Fry's, Micro Center, or Amazon or wherever, and I buy one of those components off of the shelf and I just slot it into my motherboard and we're good to go. So it's highly modular and I don't have to solder like RAM chips or ASICs or anything onto the board itself. It's kind of all pre-compiled. All I have to do is just thunk. And I hope that 3D printing gets there in the next couple of years. And one of my goals with this project is to really dive deep into how we can modularize and get 3D printing onto a footing where you can literally go down to your favorite 3D printing part store and pick up a drive unit, or you can pick up a machine frame or something like that, and you can basically part out a 3D printer and build it yourself. Not in the way that I'm going to build this one, but in a way that, you know, anybody can do it. Anybody who can build a PC can build a 3D printer in that similar vein or that similar kind of spirit decor, if you will. So that's one of the goals of this video. The other goal is just to have fun. If I stop having fun during this process, chances are there's probably not going to be another video, because engineering should be fun and you should enjoy making things. And if you're not enjoying making things, chances are you need to work on something else. So we're going to jump right in. This is kind of the introductory video where I give kind of an overview of the project, but these next couple of videos we're going to go into stuff like designing the frame, looking at the kinematics of a 3D printer, how it moves and everything like that, getting things installed, and whatever other wacky stuff that's going to happen along the way. But it's important with any engineering endeavor to take just a little bit of time at the beginning to do your research and start with a basic design or a basic concept. For those of you guys who don't know, my day job, I actually run a software company, and I conveniently am wearing a polo from that company, Mechanics Codeworks. That's the software startup that me and 3 of my best friends have started. And whenever we do brainstorming at Mechanics, we always start with a perfect world statement. And a perfect world statement goes, in a perfect world, ... And this is true for software, it's true for engineering, it's true for just about anything. So in a perfect world, I would have a 3D printer that could print more than 300 millimeters square. That's a pretty good place to start. And based on that, I can start to do my research and work backwards, do something we call reverse engineering, which is where you have a product or something and you kind of work backwards and figure out what the different cogs and the different things are that make it tick. And so with that, we can reverse engineer a perfect world statement and kind of start looking and researching options to get us to that perfect world. And the research that I've been doing, I've been looking into a lot of different 3D printer designs, and thank goodness the maker community is as good as it is, because there are tons, swaths, and myriads of different 3D printer designs out there. If you check out thingiverse.com and just type in 3D printer, you'll be greeted with hundreds of different designs. And they all have their different merits. Some are belt driven, some are lead screw driven, some are linear bearing or linear rail driven. So really you have the lion's pick of different technologies and different designs to pick from. And for my project, I chose the Hypercube design, which was developed by Tech2C. I forget the guy's name, but I've watched the video series where he assembles it. He kind of does all the R&D. And I really like the Hypercube design. The Hypercube design is a Core XY 3D printer, and what that means is basically you have the bed and it's kind of fixed in place and it goes up and down. Actually, that's not fixed in place at all. That's able to move, but it's like one-dimensional movement. So you have like a 3D printer, you have your extruder, and the extruder just works along X and Y, and then the Z kind of works its way down. So it's the core of the drive unit, or the core of the technology, is in the X and the Y, and the Z kind of just goes down, hence Core XY. Compare that to something like the Ender 3, which has this monolithic post design that mimics the Prusa i3. These machines are great, don't get me wrong. The Ender 3, the CR10, the Prusa Mark III, all wonderful, amazing machines. But for me, one of my goals with 3D printing is to do things as quickly as possible. And the tricky part about monolithic or monopost designs is that they aren't as structurally rigid as something like a Core XY cube printer is. And what that means is that if you want to drive the print head on this at any speed above around 100 to 120 millimeters per second, it gets really shaky and your print quality starts to suffer. Now, I'm not saying the Core XY is perfect in any regard either, but with the added structural rigidity of having a full cubic or fully rigid structure around it, a fully rigid machine case, there's a lot more structural rigidity, and I've seen people push Core XY printers to well above 200 millimeters per second. I can't attest to how well that prints. I haven't seen like the finished prints, but needless to say, the prospect of having a printer that can print that fast speaks to the speed demon in me, because the priority for me when it comes to 3D printing is getting things out as quickly as possible. So all that's to say, there's a bunch of different designs that you can choose from. You can do a monopost design, you can do a Core XY design, a cubic design. There's so many different options, and so do a little bit of reading on Thingiverse and check it out. Now, I'm not going to be following part for part the Hypercube build. I'm basically going to use the core technology or the core kind of design of it, but I'm going to add some things along the way too. Like, I'm going to take some old motors and some old parts from a 3D printer that kind of fizzled out on me. I'm going to see what I can scrap from that and see if I can resuscitate it. But the core of it is the, pun intended, the core of it is the Hypercube, but I'll be adding some other stuff along the way more than likely and documenting the shenanigans that ensue. And my hope is that, like I said, as you're watching this, you can kind of see how a 3D printer is designed, the kinematics that go into it, what design considerations you have to make for different use cases, like do you want more speed or do you want more detail? And all in all, just kind of document and have a little bit of fun. Well, thank you so much for watching. Feel free to leave a like if you liked the video. It helps out a lot. If you didn't like the video, leave a thumbs down. That's totally fine too. And if you want to continue the conversation about engineering, computer science, or whatever related topics, if you want to talk about cats, we can talk about cats down in the comment section. And I won't promise that I get to every single comment, but I try my best to respond to as many as I can. And chances are, if I don't get to it, somebody in the community will hopefully will. So yeah, leave a comment down below if you are so inclined. And if you want a notification every time that we put out a video, feel free to hit that subscribe button and hit the bell, because the bell notifies you, because it's the notification bell is the bell that you have to click if you want to get a notification every time we make a bell. So that was a lot of redundancy. But anyway, subscribe, hit that bell. I would sure appreciate the support, and I can't wait to see you guys in the next video. But until then, feel free to go out, create something cool, do something good for somebody, and just help the human race in whatever way that you can. Until next time, guys, I'll see you soon.